Today, we're going to pull back the curtain on one of the most powerful tools for thinking clearly, especially when you're not sure what's going on. It's called Bayes' rule. And honestly, it's about to become your mind's new superpower. Let's get into it.
All right, let's kick things off with a little puzzle. Just picture this. A woman gets a positive result from a mammogram. And it's a pretty decent test, right? It's 80% accurate at finding cancer if it's actually there. So, just go with your gut. What are the odds she really has cancer? 70%? 80%? Go on, take a guess. Lock that number in your head.
You got a number? Okay, well, I'm going to go out on a limb and say that whatever you guessed, it's probably wrong. If you guessed a high number, which most of us do, you're in for a bit of a shock. Your intuition is leading you down the wrong path, and we're about to figure out exactly why.
So, let's really dig into this medical puzzle. The whole reason it's so tricky, the reason it trips up even doctors sometimes, is that our brains are, well, they're not naturally great at juggling different bits of statistical info, especially when one piece of info is dramatic and the other is kind of boring.
Okay, to crack this thing, we need 3 key facts. First, the base rate. Just how common is this cancer to begin with? Turns out only 5 out of every 100 women in this group actually have it. That's our starting point. Second, if you do have cancer, the test correctly spots it 80% of the time. Pretty good. But here's the kicker, fact number 3. If you don't have cancer, the test still comes back positive 10% of the time. That's a false positive. And trust me, it's the real troublemaker here.
I know. All those percentages can make your head spin. So, you know what? Let's just put a pin in the medical mystery for a second. Before we solve it, let's build up our intuition with something way simpler, something we deal with all the time, predicting the weather.
First up, we need to get our heads around something called prior odds. It sounds fancy, but it's really just your starting belief, what you think before you get any new information. For example, if you're in Finland, you know there are about 206 rainy days and 159 dry days in a year. So, your prior odds, your best guess before you even look outside, are 206 to 159 in favor of rain. That's our baseline.
Okay, so you have your starting odds. Now let's add a new clue. You wake up, you look out the window, and you see clouds. How much should that change your mind? Well, it depends, right? We know that on days it actually rains, it's cloudy 9 times out of 10. But, and this is important, on days it doesn't rain, it can still be cloudy sometimes, about 1 time out of 10.
In this comparison right here, this is what leads us to our second big idea, the likelihood ratio. All this is, really, is a number that tells you how strong your new evidence is. It's a strength score for your clue. You just calculate it by dividing the probability of seeing your clue, the clouds, in one scenario, by the probability of seeing it in the other.
So, let's do that. How much stronger is the evidence of clouds for the case that it's going to rain? We just take its chance on a rainy day, which is 9 out of 10, and divide it by its chance on a rainless day, which is 1 out of 10. The answer is 9. That number, 9, is our likelihood ratio. It means seeing clouds makes rain 9 times more likely than it was before you looked outside. That's the power of that clue.
And this is where it all clicks into place. We have our 2 puzzle pieces. We've got our starting belief, the prior odds, and we have the strength of our new clue, the likelihood ratio. Now we're ready for the simple, beautiful tool that puts them together. And there it is. That's Bayes' rule. It just says your new belief, what they call the posterior odds, is just your old belief, the prior odds, multiplied by the strength of your new evidence, the likelihood ratio. That's it. No crazy math, just one simple multiplication. It's almost too simple.
Now, I know what you're thinking. That's it? But don't let how simple this looks fool you. This little equation is one of the most powerful engines for clear thinking ever designed. It's used in courtrooms, in medicine, in science, and you better believe it's at the heart of most modern artificial intelligence. It's basically the recipe for how to learn from the world.
Okay, team, we're officially armed with Bayes' rule. We get the concepts, so let's head back to that tricky medical puzzle from the beginning and use our new superpower to finally find the real answer.
Let's walk through it. Step 1. What are our prior odds? Well, we know 5 women have cancer for every 95 who don't, so the odds are 5 to 95. Step 2. What's the likelihood ratio? A positive test is 80% likely if you have cancer and 10% likely if you don't. So 80 divided by 10 is 8. Our ratio is 8. Step 3. Apply the rule. We just multiply our likelihood ratio, 8, by our prior odds, 5 over 95. That gives us our new odds, 40 to 95. And what does that mean?
It means the odds are 40 to 95, which comes out to about a 30% chance. Just 30%, which is, wow, way, way lower than most people's gut feeling, right?
So what happened? Why did our brains get it so wrong at the start? It's a classic mental mistake called the base rate fallacy. Our minds get totally fixated on the new dramatic information, the 80% accurate test, and we just forget the boring but crucial starting point that cancer is actually really rare in the first place. Bayes' rule is the perfect antidote to that blind spot.
And that's really the key thing to remember here. Bayes' rule isn't just a math formula for you to memorize. It's a mental model. It's a whole new way to think, a structured process for updating what you believe when you learn something new. It helps you see the world just a little bit more clearly.
So when you walk away from this, what are the big ideas to stick in your pocket? First, Bayes' rule gives you a clear, formal way to change your mind intelligently. Second, it's a direct weapon against common mental glitches like the base rate fallacy. And finally, understanding this is really fundamental to understanding our world today, because it's not just a tool for us. It's how AI systems are learning to navigate and make decisions in our very uncertain world.
So I'll just leave you with this question. Now that you've got this tool, this mental superpower, what are you going to do with it? The next time you see a shocking headline or a surprising statistic, how are you going to stop, check your starting point, and update what you believe? The tool is yours now. How are you going to use it?